Are we good? Okay. So this is a ginormous room. Does everybody want to gather in a little bit and make it a little more intimate? So anyway, good afternoon, and thanks everybody for coming. Thanks to Amazon for having me here. So today I'm going to be talking about how SES is partnering with Amazon to build what we call hybrid connectivity, but essentially it's to build through satellite connectivity, build optimized connectivity from end user communities, no matter where they are in the world, to their workloads in the cloud. This is going to be very intimate. I'll get through this as quickly as I can, and if there are any questions towards the end, I'll certainly invite those. I'll skip past this here. I guess the first thing you might want to ask yourself, if you don't want to ask me, is what is SES, a satellite communication provider, doing here at this event? Well, we were invited here by Amazon, I think, really to underscore the value of the collaboration between a cloud service provider and a network service provider, because in the end, the power, the potential of the cloud is going to be inextricably linked to the network that underpins it. It's going to be dependent on the coverage, the performance of the underlying network. So at SES, we focus on satellite communications. And one of the things that we like to think about satellite communications is it has a very unique superpower. And the superpower is that it reaches anywhere and everywhere. So we sort of think in terms of, with that kind of a connectivity capability, we really do have the ability to connect anybody to the cloud, no matter where they are. But similarly, as we'll talk about a little bit later, working with partners like Amazon, we have the ability to take the cloud to anywhere. And both of those are really, I think, important dynamics. What it's really going to allow then is a collaboration to ensure this maximum reach and availability of really the world's most powerful cloud to any community of end users, no matter how remote they may be, no matter how much they're in motion, and give them the same experience as if they were in a dense urban center. So you may not know a lot about SES, so let me take a minute or two just to give you an introduction who we are. So we're a global satellite communications provider, in fact, the largest in the world. And we operate the world's only multi-orbit fleet, meaning we combine geosynchronous orbit satellites, or GEO as we call them, both with wide beam coverage as well as targeted high throughput beam coverage. We combine that with the world's only medium orbit fleet, or MEO as we call that. Those fly closer to the Earth, and because they do that, they actually can provide a lot more capacity with a lot better performance and latency metrics. So very, very high performing satellite-enabled bandwidth. So we combine those assets with the world's largest fleet, as I mentioned, gives us coverage of 99% of the globe. And with that coverage, then, we can connect to a wide range of end-user communities. We particularly are effective for end-user communities that fly or that float, and there's really no other way to reach them. Planes, ships, oil rigs, whatnot, or that are on the move. So it might be mobile endpoints on a terrestrial footprint, things like, for instance, a mobile forward operating base or in a military application. We also are deployed on an event basis. So sometimes there's an event, a planned event, where we need to light up much more capacity, a Formula One race perhaps. But sometimes those events might be, unfortunately, natural disasters, and we need to augment or even restore connectivity when these events happen. So we're deployed a lot in those scenarios. And then finally, we augment other network providers' networks. So as an example, we support telecom or mobile network operators' footprint. We augment it, we extend it, allowing them to roll out mobile services, 3G, 4G, and in the future 5G, wherever they need coverage extensions to connect remote areas. So that's who we are. There's a little bit of an emphasis in today's talk on public sector, so I wanted to give you a little bit of dimensioning on that. Our connectivity really serves a pretty broad range of government, as we say in SES, or public sector, as Amazon says, end user communities. So you can see here some of those metrics. 56 different government clients across 29 countries. Here within the US, we work with 15 agencies, serving 15 different unique clients within those agencies. Across the world, in 26 countries, we've got footprint and presence for sales and support and technology offices, all serving the public sector. So that's a mix of civilian communities, military communities, and NGO communities. So this is a pretty significant part of our business. What do we do for them? What capability can we provide? Well, as I've already talked about, we've got a pretty broad coverage using a hybrid GEO and MEO fleet. So we can provide a lot of capability and connectivity through that fleet, augmented with teleport services, which is essentially where satellite traffic lands, secured teleport services, really to build on end-to-end secured traffic and communications. We can transmit across all of the bands in satellite communications, C-band, KU, Ka-band, but I also wanted to highlight a couple of military-specific bands that we can work with, X-band and military K. This all allows us really to offer fully managed end-to-end connectivity and communication services to a pretty wide variety of public sector end users as a managed service. So not just the megabits flowing, but the support and the infrastructure in place to make this consumable in as turnkey a fashion as possible. So what we're able to enable with this, is a range of applications, both for civilian, for military, and also for NGO applications. Example would be some secured information gathering or surveillance applications, really that are globally scoped. We can support that with a connectivity fabric. For civilian agencies, we can assist with e-government, e-learning, e-health applications. For military applications, it's really about operational mission support, but also for troop morale, troop welfare. So there's a number of different ways that our connectivity is used. How we differentiate, we are, as I mentioned before, we're unique in the industry in that we do have a multi-orbit, multi-band fleet, really allowing us to tailor our communication services to the specific needs. Sometimes you're looking for broad coverage with economics as the primary concern. Sometimes you're looking for targeted capacity and connectivity with very high performance. And so we've got options for that in our fleet. And we're continuing to invest at SES into our fleet. I'll just mention briefly today, particularly on the MEO side, we're coming up next year on a launch of the next generation of medium Earth orbit satellites that we call O3b mPOWER. If you want to know more about that, then please come see me later. Let me get a little more specific then, some user stories or some cases. I'll start with some projects that we've done with the United Nations. Here, their situation involved the desire to roll out more extensive cloud services, in particular ERP capabilities, across 7 of their agencies within the UN, really serving 22,000 end users across the globe. They previously had challenges doing that, largely because of the stability of the connection infrastructure in some of these places where they needed to operate. It could have been just the quality of that, but sometimes these were also conflict zones. So that was really an obstacle for them to really proceed with their cloud or digital transformation ambitions. So what we were able to offer them was through our MEO fleet, we were able to offer them essentially a blanket of capacity that they could redirect wherever they needed it to go, highly scalable, highly reliable, high performance, and we were able to assist them also with some of the logistics of deploying and redeploying some of their terminal infrastructures So as their need changes, the connectivity map changed as well. And what that led to really is, they had a stable communications infrastructure, secured in some cases, that really optimized their cloud application experiences, and in fact led them to adopting more and more cloud services because now they actually had a foundation which was fit for purpose for doing that. That clearly improved productivity amongst the staff, the 22,000 remote workers. But the other effect that it had was essentially really improved the data integrity of data collection and data that was feeding analytics operations. And so it really led to other applications that were working much better than they did before. Another example would have been for the United States Department of Defense, this time for Africa Command. So in 2018, SES was awarded an almost $25 million contract by the DoD specifically for their Africa operations, their Africa Command operations. And again, this time it was using our medium Earth orbit fleet, our MEO fleet. So again, a way to think about this was a blanketed capacity that we were able to target specifically for their Africa Command operating geographies. Gave them very dedicated, flexible, secured bandwidth that they could deploy to their end users, be it mission teams or other civilian agencies they were supporting. It actually consumed quite a bit of capacity, I guess, in satellite terms, an entire MEO beam, 400 plus megahertz of capacity. When you translate that into bits, that's gigabits and gigabits of information that they were able to exchange over the MEO fleet. Last example I'll share with you is for Burkina Faso. So we deployed capacity in Burkina Faso as part of the ICT infrastructure for the government of Burkina Faso. This was in support of applications, e-applications for government, for education and for healthcare across 43 of the provinces in Burkina Faso. If you're not familiar with where that is, it's a West African landlocked country where quite a lot of it is very remote and difficult to reach. So this project was really about how to augment their wireless and fiber terrestrial infrastructure to build a hybrid connectivity map using satellite as a way to reach 880 at the time additional sites to connect villages, schools, government outposts, et cetera. That number keeps growing, as does the capacity that we're serving them. So they started with 600 megabits of capacity for those 880 sites. That continues to grow. So that's SES, and what does that have to do with the cloud? Well, at SES, certainly the thing that we recognize is satellite networking is like any other kind of networking, wireless networking, terrestrial networking, et cetera, increasingly carrying more and more cloud traffic. And so we see this manifesting itself in two ways. The first one is quite a lot of the capacity that we carry is headed to the internet, and so we can see much of that internet traffic now as to access public software as a service addressable capabilities, and more of the percentage of the bandwidth we serve is for that. But the other thing that we've noticed is that there's a clear increase in connectivity to other types of workloads. Workloads that are more infrastructure oriented or platform oriented. And so from SES's perspective, we've been serving internet connectivity as part of our service offerings for quite a while, but we're starting to recognize that our connectivity now needs to maybe be directed to an additional and growing traffic target, which is directly into the cloud, into something like AWS Cloud. So what we've been focused on is how do we take our superpower and evolve it really to offer the value proposition of no matter where you are in the world, you're one step away, one hop away from the cloud. So in executing on this evolution or this strategy, I mean, we realized very quickly that one of the things we needed to do was form some impactful partnerships with the major cloud service providers, and of course, with Amazon. That was one of our first thoughts, is how can we join forces with them? And we started by getting ourselves certified as a partner for their Direct Connect program, for fulfilling their Direct Connect technologies. And we were, in fact, the first satellite operator to have achieved that partner status and to have joined that partner program. So if you're not familiar with what a Direct Connect is, I'll give it a quick working definition. A Direct Connect is essentially an alternative to cloud connectivity, an alternative to internet-based cloud connectivity. So this is a way of building a dedicated connection from traffic sources, would be they remote or aggregation points, right up to the edge of the AWS infrastructure, and done in a dedicated way with much better performance and capacity metrics associated. So as it says here, it gives a flexible, secure, reliable access to the AWS data centers or peering points from virtually anywhere when you couple that with satellite technology. It's dedicated connectivity, and as I mentioned, it bypasses the public internet, so it provides a much more predictable and deterministic network performance, which translates directly into how well you're connecting workloads, which translates directly into how well the applications perform. A Direct Connect is available in a range of different speeds, as you see here, and it can be offered as a managed service to any of the cloud customers backed by SLAs, so we can assure that their high-performance connection is always performing as a high-performance connection. So this was one of the first steps we took, and we're very proud to have had that alliance with AWS. What does one of these look like in a very simplified way? And the best way to read this is from left to right. So on the left, there's a collection of end-user communities there. You'll see oil rigs and cell towers, et cetera. You'll also see an icon there that says Edge Compute. So maybe it's not a cloud user necessarily, but it might be an edge compute infrastructure that's hosting remote or disaggregated cloud workloads that also need to connect back into the cloud environment. Now, where this is especially relevant for SES is because of the end user communities or those remote sites that we're really good at reaching. Anything that flies, anything that floats, or anything that otherwise would be difficult to connect using terrestrial or conventional means. So we aggregate that traffic locally. We push it through a modem, through a satellite terminal, over a satellite hop, and then we land it into a traffic landing point that we refer to as a gateway or a teleport. And then from there, you make choices about this aggregated traffic. Where does it go? So I mentioned before, a lot of it will continue to go into the public internet, and that's some of what we can do is peer into the internet. Some of it will go into a corporate or an agency wide area network, but increasingly, a lot of it is going to start moving directly into the cloud. So that traffic separation, then we use SES's core terrestrial network, which we operate a pretty sizable footprint on that, essentially to take the traffic up to either the nearest and or the best peering point within AWS's infrastructure that it can reach the customer's workloads in the most optimal way. That's effectively how we build these things. But what are they used for? Where is this most useful? Because obviously quite a lot of the traffic going to the cloud these days is carried over the public internet. It's secured using IPVPNs, for instance. And that, for many applications, works really well. And I think the last 18 months in COVID that gave me this hair, that sort of has proven that we can work in virtualized ways over the public internet, and that works pretty well. So really, these direct connects, this dedicated connectivity is kind of intended to reach maybe a different kind of workload, right? So where it applies best is if the workloads you're trying to reach are more infrastructure-oriented or platform-oriented. So they're still privately addressable as opposed to public internet addressable, but they're hosted in the public cloud. Right? These now are usually workloads that are participating in DevOps or other kind of application development environments, and performance is really going to matter there. So that's the kind of workload that benefits, I think, more from one of these Direct Connect connections. Another one is another condition would be if it's a more targeted set of users that are trying to reach a more targeted set of endpoints or workloads. So it's not necessarily what you would apply if you're trying to reach everybody everywhere in a large-scale enterprise or a large-scale agency. You still may need the scale and the reach of the internet in order to do that cost effectively. But if you have infrastructure-oriented workloads, if you have a targeted set of community or end users, then yeah, these dedicated connections start making an awful lot of sense. And so a couple of examples I've noted here. Maybe it is a secured application development environment, maybe a DevOps environment. Maybe it is an industrialized operation, in some cases perhaps hard to reach unless you have satellite communications, that's undergoing significant digital transformation and maybe adopting a lot of IoT. So energy operations, mining operations, commercial shipping operations, these are the sorts of communities that, at least in satellite world, resonate a lot with that. From a public sector or a military, in the military sphere, maybe it's mission critical applications that really rely on highest performance communications, secured communications. And again, this is where the Direct Connects can really make a lot of sense. So at SES, at least, we're seeing more and more examples of this, which is really leading towards, I think, an increasing adoption of something like AWS's Direct Connect. What benefits does it bring? I think I've already touched on some of this here. Well, it's faster, right? So it's going to scale more easily than trying to scale connections and capacity up over the public internet. It'll do it with better performance. It'll have a more deterministic profile around latency, around jitter, around the things that matter to make the workloads actually connect to each other most effectively. Flexibility and control. So you don't have a lot of control over how you route things over the internet, but here you do. You have an awful lot of flexibility about where traffic goes, and it can go exactly how you need it to go. It's certainly going to be more secure than the public internet. Even with IPsec and other kinds of technologies like that, there are just a lot more ways to secure the traffic. And it can be more cost effective for cloud users. Sometimes they pay what are known as egress charges. I guess you might know this. Traffic leaving a cloud service provider's environment usually gets tariffed on a volume basis. Depending on what the workloads are, depending on how much traffic it needs to flow back and forth, a Direct Connect is an alternative to the egress charges, and on balance, it may actually provide some optimization of the overall cost of ownership. So there are a number of reasons why these Direct Connects, I think, bring a lot of business value to the cloud user. And just to underscore a couple of points here, as far as how this applies to satellite, I mean, with SES, what we're saying, look, we're a logical way of bringing the Direct Connect construct all the way out to even the hardest to reach points in the planet. And it allows any end user really to start choosing how they want their cloud traffic to be handled alongside their non-cloud traffic, be it internet-based, leveraging these Direct Connects to get sort of this a similar experience as they would in any other endpoint that they serve. With satellite, I mean, we've got other options on how we can secure traffic. We can align with the layer 2 and the layer 3 security options that are typically made available for these kinds of connections. Technologies like IPsec, MACsec, and other types of encryption. And then the last point I would raise is just the flexibility of satellite generally. I mean, we really have the ability to tailor coverage and communication based on specific needs, how much capacity, where it's landed, is it symmetric or asymmetric? There's a lot that can be done in satellite communications to really match that to the end user needs. So we start building that out and then layering on top of that some of the cloud connectivity capabilities, and I think we really start seeing the power of satellite plus cloud. So I'll close by sharing sort of our high-level view about how SES and ACS working with AWS is going to support public sector needs. And on the top of this slide here, I've represented a few applications, kind of public sector-focused applications, whether they're situational awareness, whether they're secure hosted payloads, humanitarian support efforts, e-government, as I mentioned before. So in constructing these applications, this is usually based on a stack of broadband services, interconnecting cloud services, and in some cases augmented with IoT capabilities. So the bottom half of this slide really is how we see SES contributing to this. And it starts with our superpower. It starts with what I've called here the base SATCOM connectivity across our multi-orbit fleet. And then we complement on top of that a range of value-added networking capabilities, analytics, security appliances, content filtering, and in some cases, local extensions to the end-to-end connectivity map. So beyond the satellite terminal, we can establish Wi-Fi bubbles, we can establish cellular bubbles, all as part of how do we connect to the cloud user. And then on top of the value-added networking capabilities, what I had mentioned, our alignment now to the cloud, beginning with capabilities like Direct Connect, but I think with partnering with people like Amazon, we definitely see a trajectory on how we can collaborate on edge or remote compute enclosures to distribute workloads more efficiently, how we can establish 5G connectivity plants, how we can establish IoT capabilities on top of those. So there's a lot of possibility to take this very far with AWS. Last point I'll mention here is, we also envision this as a capability that should be consumed almost in a cloud-like model, SATCOM as a service. To make that possible, and we've been investing in API capabilities, standardized API capabilities that lets a partner service provider consume the SES capability, package it up in support of these public sector applications. So we're really excited about this trajectory. We're really excited about the partnership that we formed with Amazon to get us from here to there. And with that, that concludes my comments. I'm not sure how much time I have since my clock's not running, but time allowing, I'm happy to take any questions. Yep.
Government agency?
Not here, but I'm certainly happy to to show that to you later. I don't have any slides with our hardware solutions, right? But we have obviously different types of terminals and other sorts of remote enclosures for either mobile applications, for higher bandwidth, for lower bandwidth applications. We've got a range of things that we can offer as part of the managed service. We've got a range of consumption models for those hardware enclosures as well. We can offer them as an MRC-based managed service, or we can sell them to the customer. Every opportunity might have a different set of needs there. But maybe we can talk after this, and I can see if I can pass you some information. It's just not something I have here with me.
So do you consider as additional carrier to Verizon, AT&T, T-Mobile in the 5G market, in transport market?
Yeah, I'm having a little trouble hearing you, but I think what you're asking is, do we work with other traditional carriers?
Yes.
Yeah.
What I meant is, are you sell your service directly to the customer, or do we have to go through a carrier, a 5G carrier, and then on top of that we have an agreement with SES, and then to have a satellite to transport?
We do both. We do both. So here we mentioned the partner service providers. So we work with a range of different partners. In some cases, they serve more as a reseller of SES capability. In some cases, they serve as a solutions integrator that incorporates SES capability into maybe a larger solution space. Some of those are names you would recognize in terms of the globalized telcos. Some of those are fairly industry-specific solutions integrators. Increasingly, we're also working with Amazon to see how we can package up combined value as well. So in some cases, for some of our markets that we serve, we'll go directly to the cloud user and we'll sell connectivity to them. A good example of that would be a lot of our maritime business and the cruise industries that we work with. That's how internet gets to a ship. In some cases, we work with people like you've mentioned there to package up maybe a more comprehensive ICT solution. So we do both. Any more?
How do you connect your endpoint? I work for a government agency, and I'm exploring new technology. I'm looking at the 5G, etc., but it's not ready for what we want to accomplish. Our staff are traveling across the nation to different courthouses, etc. They are sitting inside the building. It's like a bunker for me because concrete, cement, etc. We have a poor quality internet access, and sometimes they need to have access to our mission critical application, now hosted in AWS. How do you interconnect the endpoint with satellite going back to our AWS infrastructure or back home?
Well, at a high level, this sort of describes it again, right? So the premises or the endpoint, it may have an additional connectivity map associated with either cellular or Wi-Fi. That will tend to aggregate back into an SES resource on site. And then that resource on site then starts feeding essentially the satellite link. So just think of the satellite link as a wire, as an extension, right? It's a very powerful one, but that's what it is. So that it'll land traffic down into our gateways, and we've got gateways all over the planet. And then from there, we leverage the power of our core terrestrial network to essentially route traffic wherever it needs to go, right? So in today's conversation, this is about the partnership we formed with AWS to say AWS has predefined peering points for their network and their cloud infrastructure. If you go on their website, it'll list them out where they are, and we can get to those essentially in a very optimized way through completing that circuit, that backhaul circuit, if you want to call it that, through our core terrestrial network. So the workloads then are connected. And once the workloads are connected, then the applications can synergize. You can distribute the applications a number of different ways. So at a high level, that's essentially what we do. How do we do it? We have local networking capabilities that we can support. Typically, the agency or the customer, the enterprise we work with also has local networking resources. So we peer those. We aggregate those into a transport link, which is satellite-based. When we land it in our gateway, we segregate the traffic, and then we put it where it needs to go.
Thank you so much, Carl. Really, really appreciate you. A little over time, so appreciate you handling the Q&A.
Oh, now it's doing that.
Yeah, thank you. So the next session in this room will start at 2:10 p.m. It's going to be a session on enhancing the AARP member experience with AWS. So that'll start at 2:10 in this room. So we really appreciate you taking the time to come to this session. We appreciate Carl for delivering a great session. And as a reminder, if you could complete the session evaluation in the app, that would be super helpful. So have a great day, everybody. Thank you.